Moving on into transforming quadratics, I actually want to start off by talking about what a transformation is. Okay, so the word transformation can be broken down into transform. Trans simply means to change. Form is like the orientation. Place. Or the way something looks. Okay. Now all quadratics, okay, are related to the quadratic parent function. What is a parent function? A parent function is the most simplest, basic form of a function that satisfies its definition. So when we first started this unit, I went over and described what a quadratic was. The parent function of a quadratic, again, this is kind of important, is this. F of x is equal to x squared. The shape is a U shape. It's table. And you can get all of this by going to Desmos. Again, the previous video we said the magic number of points was 3. So -1, if I plug this into x, so -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is also 1. I'm going to go one more just for fun. When I plug 2 into the function f of x is equal to x squared, anywhere there's an x, I'm going to put a 2. So 2 squared becomes 4. The graph, again, is very similar to the shape. The big thing is you just kind of, that's the point 0, 0, 1, 1, 2, 2, 3, 4, 1, 1, or -1, 1. And then this will be your graph. This is what a lot of your transformations is going to be based off of in Math 2. In different classes or in Math 3, you'll actually have the parent function be moved around, so already transformed and then transformed from there as well. So just kind of a heads up, I will give y'all some examples, that way you can be prepped going into next year. Okay, but again, just wanted to give you a heads up with that. Now the equation, again, is just f of x is equal to x squared. Earlier we talked about the degree, right? This right here is your degree, right? It's the highest number that a variable is raised to. And that's your bubble map for the quadratic parent function. Now, transformations can be broken into 3 broad movements, and that's what this tree diagram is going to represent. Okay, so the first one we're going to look at are reflections. The graph changes its shape, so you know a reflection has occurred if the graph changes its shape. So a U is going to reflect, right? Think of a mirror. Or flip. So if I flip a U, it's going to become an N, and if I flip it in, it'll become a U. You can have directional shifts. Now, directional shifts are my, second, or what I would consider to be the second easiest, next to reflections. So vertical is up and down, or horizontal is left and right. The last kind of transformation you'll have in regards to a quadratic is a stretch or a shrink, okay? Now, this is going to be the absolute toughest. So what I recommend is you save this one for last always. If you're not 100% sure, save it for last. Now, stretches are very narrow. A shrink is the exact opposite. A shrink is very wide. Okay. I'll say a stretch is extremely tall, where a shrink is very short and flat. And I'm going to save these two. What I want y'all to do is think of words that could fit here after we go through and do some examples. Once we actually do some examples, we'll come back in and actually fill out this multi-flow map. So on page 12, we'll go over a few examples. Now, to start with, I need to talk about some more vocabulary terms. Your pre-image is what comes first or before the transformation. Your image comes second. So the pre-image this time is going to be the skinny one, and the image will be the wide. So to make my life easier, I'm just going to highlight and let my know skinny is blue, image is red. So I'm going from blue to red. Now, like I said, reflections are probably the easiest, and it's either just a yes or no kind of answer. So the pre-image looks like a U. The image looks like an N. So U to N has changed shapes, therefore a reflection has occurred. Now, to figure out the vertical shifts, the horizontal shifts, and the vertical stretches and compressions, or stretches, shrinks, compressions, I advise you to find or locate the vertex of each of your functions, right? We focused on vertex when we first started talking about the key features, and even in here, it's going to be or play a huge part of doing transformations. So once you locate the vertex of each function, I like to actually write it out. So again, -5, 2 is the blue one, and then the red one is 4, -3. And to find horizontal and vertical shifts, all you do is go from the vertex of your pre-image to the vertex of your image, and you will always get it right. Okay? So another way you can think of it is, do I move left, right, up, or down? So because I start with the blue dot, or the blue graph in this particular question, and I need to get to the red dot, I'm going to go to the right, and then I'm going to go down. Okay? So absolute worst case is I go right and I go down. This is going to get you like a high C, low B, just by being able to do reflections and then your directions. Where you're going to get into the high B's, the low A's, is by how much did it move to the right, or how much did it move to the left, or how much of a vertical shift did it have. So to do that, just make you a number line, right? I always like to put 0 in the middle. It gives me a good starting point. 4 was an X value of a vertex, and then -5. Okay? So from 5 to 0 is 5. From from 0 to 4 is 4. You add them together, and you go to the right 9. Okay, distance always positive. Vertical shift, same deal. Except this time, I'm going to draw a horizontal, vertical number line because we're talking about y values. Again, 0 still goes in the middle. 2 is bigger, so it goes up top. -3, smaller, it goes on the bottom. -3 to 0 is 3, 0 to 2 is 2. Add them together, and I get 5. So I went down 5. Now, vertical stretches, compressions, or stretches or shrinks. Skinny to wide is a compression. Wide to skinny is a stretch. The only way I remember this, and like the tip I can give you, is that stretch, if it ends on a stretch, or if it ends with an S, then it's a stretch. Okay, so skinny, wide, compression, wide, skinny, stretch. So I went from skinny to wide, therefore it is a vertical compression. Try these other ones on your own. Here, these last two, I give you the freedom, right? I don't care which one is the image, which one's the pre-image. However, depending on what you choose is going to affect your outcome. So if you choose red for this middle example as your pre-image and your blue as your image, and somebody else does it just the opposite, your answers are going to be backwards. Okay, so keep that in mind if you talk with each other and kind of compare answers.